Hello, welcome to this channel again. In this video, we are going to learn about integration by Monte Carlo method. So, we will discuss about the integration of a function by using the method of Monte Carlo. Okay. So, first of all, let's learn what is Monte Carlo method. So actually Monte Carlo method is the method of finite integration of functions using random numbers. So actually Monte Carlo is the name of a city, okay, where the casino game were very famous. Okay, so casino game uses a random process. So from that we have now the Monte Carlo method, and it uses concept of random numbers. And in this video we are going to discuss about the Monte Carlo method, which gives us the integration for the limit from 0 to 1. Okay, this means limits of integration is between 0 and 1. And in number 2, integration for other limits. Okay, for the limits having value other than 0 and 1. Okay, and we will also see the two-dimensional integration using Monte Carlo method. Okay, and you can see this line: Monte Carlo method is more precise and simple way to determine the finite integral, and it also helps us to determine the error percent. Okay, percentage in the error of Monte Carlo method. Okay, so we will discuss about all of this. We use Monte Carlo method to determine finite integral in fortran. Okay, this video explains you to use the Monte Carlo method for the integration in fortran. Okay, so algorithm for fortran program is, or algorithm for finding the integral value using Monte Carlo method is listed as shown here. So in first step we start the fortran program. Okay, that is start program, and in fortran program we have to declare the function and variables. That is f is function and x will be the variable. Okay, and from x we will define some other necessary variables as well. And in step 3 declare integers if necessary. Okay, so integer is needed to generate different numbers of random number. Okay, and to generate the random number we need to call the function in intrinsic function of fortran program called as rand. Okay, we will call this function to generate the random number, and define limits of integration, a as lower limit and b as upper limit. So in first case we will use a as 0, b as 1, because we generate the random number from 0 to 1, between 0 to 1. Okay, so in that case limit of the integration will be a is equal to 0 and b equal to 1, and determine the sum of the function of random numbers. We will generate the random number, then we will define a function of that random numbers, and we will find the sum of the function of the random numbers, and then we will determine the average of the function. Okay, average of the function will be sum of the function divided by number of the random numbers. Okay, this is number of random numbers. Okay, I have missed here to type the random. Okay, and in 8th step we determine the difference between the upper and lower limits of the integration, as b is taken as upper limit, b and a taken as lower limit, and their difference will be b minus a. After determining the difference between the limits of the integration, we multiply the average of the function, any it means this value multiplied this value by the difference of the limits to get the integral value as this. Okay, we called this integral value as estimated integral. So this equals to b minus a times average of f. Okay, so this is how we can calculate, we can estimate the integral value of function by Monte Carlo method. This is simple way. And we can also calculate the error of this method. Okay, and for this we need to have the real value, integral value. Okay, so for this real integral value will be f of b minus f of a. Okay, here I made a mistake. This must be f of a. Okay, and of course I have to type here random. Okay, this is a number of random numbers. Okay, we have generated. Okay, so this is how we can estimate the integral value by Monte Carlo method, and we will need to determine the real integral, which is f of b minus f of a, and we will calculate the percentage error, which is equal to 100 times real integral minus estimated integral by real integral. So this is how we can calculate the percentage error in determining the value of the integral by Monte Carlo method. Okay, in this way we can estimate the integral value by Monte Carlo method. So this is simple definition, and these are the cases that we are going to deal, and this is the algorithm. Okay, for determining the integral value and error calculation. So thanks for watching, and now let's go to the fortran code. So for this let me close it, and let's go to here. I have created many fortran files, 1, 2 and 3, and I have to open the terminal on this directory. Okay, so for this you have to just right click and open in terminal. Okay, in this way terminal opens like this. Okay, and I am here desktop, computational and integral directory. Okay, now if you have first of all we have to deal with the integration between integration for limit 0 to 1. Okay, for this case I have created a fortran file here. Let me open it and explain you some of the basic information. So this program Monte Carlo integration using random numbers, and lower limit is 0, upper limit will be 1, and generated random number lies in between 0 to 1. Okay, these limits mean these limits mean generated random number lies in between 0 to 1. Okay, so as I have discussed in algorithm, so we simply initialize the fortran program with a program name called, I named it as MC integration. Okay, and implicit none is there, and we define a function externally. Okay, so I have defined a function using double precision, and it is external function, and which is denoted by f. Okay, and double precision we have to declare some variables as well. These variables will be upper lower limit a, upper limit b, and of course there will be random number x, and sum of the function, average of the function, integral, Okay, in place of estimated integral, here I have named the estimated integral as integral only, and this is a real integral, and this will be error. Okay, error. And I have also defined here uh, some integers called, which is denoted by I and n. Okay, so as we have discussed here, I have shown here the lower limit is 0 and upper limit is 1. So I have written it in the program like this. Okay, a is equal to 0 dot d0, because it is in double precision, so we use d0, and b is equal to 1 point d0, and n is the number of the integrals, random numbers to be generated. So this will be this much. Okay, 110,000, 110, 110,000, 110, 100,000, 10,000, 100,000, million, 10 million, 100 million. So this is the number of the random numbers to be generated, and sum we will have to calculate sum. Okay, sum of the function as sum1, and for all of these we have to call as random to generate the random number. Okay, using the seed as this. Okay, you can use any number, higher number. Okay, I have used from 1 to 9. Okay, so we will use do loop to generate this much random number. Okay, so do I takes value 1 to n, so n is here. Okay, defined here. N must be very large. Okay, and x is equal to rand. Okay, this is how we can generate random number, and sum1 is equal to sum1 plus function of x. And let me tell you first that I have defined this function externally here. Okay, okay, this is how I have defined the function. Double precision function fx, double precision x is also in double precision, and f is equal to x square. Okay, the function is x square, whose integral value is to be determined, and n function. This is how we have defined the function externally. Okay, now after finding the sum of the function, we have to end the do loop and find the average. So average is equal to sum1, this sum1 by n is the number of random numbers. Okay, or the number of the function, you can also say, because number of this value will be equal to number of this value. Okay, so integral is equal to b minus a, this is difference of the limits, times average of the function. Okay, so print the calculated integral value is this. Okay, this will print this value, which is estimated integral value. For error calculation, we have to determine the real integral. So actually the integral value of x square is x cube by 3. Okay, x cube by 3. So using the upper limit and lower limit, we have for upper limit this is x cube by b cube by 3. Okay, for lower limit this will be a cube by 3. So I took the 1 by 3 common here, and error will be let me write here first abs. Okay, this is absolute value. Okay, so that there will be no negative value. Okay, so this is the formula for error calculation. Okay, I will provide this file in the description. You can download the whole file of this tutorial from the link provided in the description. Okay, and that will be easier for you, and I suggest you to type the code yourself. Okay, do not copy it from the file I have provided in the description. Just take the guidance from the file, and you have to, I recommend you to type the code yourself, so that there will be no mistake, okay, in the codes. And print real integral, and print error in Monte Carlo method is error. It will also display the percentage and end program. This is how the this is step of the fortran code completes, okay, number one. So now let's this code, okay, and let me tell you the name of this code file is mc underscore into 01.f90, okay. So let me run it in the terminal. This is mc, okay. This is how you can run the program. So press enter, and to see the result you have to type this, okay, and it will show the result as calculated integral value is 0.02, 0.33 and so on, okay. This is the estimated value from the Monte Carlo method, okay, and this is the real value we have calculated from using the simple formula. And this is the error in Monte Carlo method, error in percentage, and it is 1.25 and so on into 10 to the power minus 3, okay. It means 0.00125 percentage, the percentage error in Monte Carlo method, okay. You can see the difference. So this is how you can estimate the integral value using Monte Carlo method for different function using the limit from 0 to 1, or between limits between 0 and 1, okay. So let's move on to next step, and this is integration for other limits, okay, other than 0 and 1. For this I have also created a file here, so let me close it and open this file, okay. This is Monte Carlo method using random numbers, okay. So for this, lower limit is a and upper limit will be b, and generated random number lies in between, okay. This means it is not 0 to 1, it is a to b, okay. It depends on the value of a and b you provided, okay. So for this also you simply initialize the program with the name of the program as MC integration, implicit none is there, define the function as double precision externally, okay, as f, denoted by f, and double precision we have to declare variables as double precision using double precision. A, b is there, and x, y, sum, average, integral, real integral, and as before, okay. All values are as before. So integers are I and n. So there is no this is the case for the limit of the integrals other than 0 and 1. So we have to provide the value of a and b, lower limit and upper limit. So write program, this command says enter the value of the lower limit. So you have to, when you compile the program, you have to provide the value of a, and similarly value of b you have to provide. And also, as we have seen before, you have to enter the number of random numbers to be generated. We have used here the number of random numbers as this, okay. You can input provide this value when you after you compile the program, and we simply call as rand for generating random numbers. And we have to find the sum of the function. So first of all, we define sum1 is equal to 0.d0, and we use do loop I is equal to 1 to n. So x is the random number we generate from here, okay. And as we are going to estimate the integral value used for limits other than 0 and 1, okay, that means a and b, okay. So for this we have to define upper limit. Okay, upper limit how much. Okay, so this program, this code generates the random number from a to x. From a means the value you provide from here. Okay, so it will be less than 0, that is in points, 0.1, 0.2, or it will be greater than 0, 1, 2, 3, and so on. And don't remember that b always be greater than a. Okay, so y is equal to a plus x times b minus a. Okay, this is also the form you can use. And print xy. So x is actually the random number which will be between 0 and 1, and as the limit is changed here other than 0 and 1, so we have to calculate the modified random numbers. So the modified random numbers is y. Okay, here, so x is modified to y. Okay, according to the limits of the integration you provide. So with these modified random numbers, we calculate the sum of the function. Okay, sum one is from here and plus f of y, and this will calculate the sum of the function n do, and the function average of this function is defined as avg is equal to sum of the function by divided by number of the random numbers generated. Okay, an integral value will be difference between the limit of the integration times the average we have calculated here. Okay, and print the result at print the calculated integral value will be integral. Okay, same as before. Okay, so here we have to also calculate the error. So we have defined the same function, okay, as before, x square. So for calculating the error, we have to determine the real integral first, which is of course b cube minus a cube by 3 dot d0. Okay, and error will be absolute value of real integral minus this estimated integral divided by real integral times 100. Okay, you can bracket here as well. Okay, let me close it. Okay, we don't need to provide this value, actually this bracket. Okay, and print real integral value as real integral, and error in Monte-Carlo method is error. It will show us the percentage value also, and this ends the program. Okay, this is the format of the program for the integration using Monte-Carlo method for the limit of integral other than 0 and 1, that is ab. Okay, we have to provide value of a and b. So now run the program and see the results. Okay, so for this let's go to the terminal and see. This is the file, so it contains capital M. So let's type first G fortran. Okay, and simply capital N and press tab, and it will show you the complete name of the file. Okay, see, now press enter. Okay, and there is no problem in code, so it is correct. Now you have to see the result, you have to type this and press enter as well. So here it says enter the value of lower limit, so it will be other than 0. You can also use 0, so for now let use 0. Okay, first lower limit is 0, upper limit is 1. Okay, and let the number of generated value be this. Okay, and if you press enter, these all are the random numbers, okay, generated. Okay, it will be very large number of random numbers. Okay, it takes some time. Okay, and after generating the all random numbers, it will also show the results for the integral value and the percentage error as well. Okay. It is taking time. Let's wait for a few seconds. Okay, so this random number is, these are very large number of random numbers. Okay, there are I think 2 millions random numbers. Okay, and this is calculated or estimated value of integral. Okay, and which is 0.033 and so on. Okay, and this is real integral value we have calculated, okay, by direct formula. Okay, and error in Monte Carlo method is calculated, estimated as this. Okay, which is 5.9 and so on into 10 to the power minus 2. So it is obviously 0.059 and so on. Okay, percent. So this is how you can estimate the integral value of the given function by using the Monte Carlo method for the limits of the integral other than 0 and 1. So let me show you defining the limit other than 0 and 1. So this we calculated this using 0 and 1 as a limit of the integral. Okay, so let me show you calculate the limit. Let me clear it first. Okay, so let's run the same program again, and so in this case we will enter the value of lower limit as 2, or you can use any real numbers. Okay, 2.5, 2.3, any, and upper limit is let it be 10. Okay, and enter the number of random numbers to be generated. So let it be so we have entered a very large number before, we took few seconds to generate the result. So let this time enter only 10,000 random numbers. Okay, then press enter, it will show the result like this. Okay, and see, this column contains the actual random numbers. Okay, x, and this is y, so this is modified random numbers. This column contains modified random numbers, from which contains the number from 2 to between 2 and 10. Okay, from 2 to greater than 9 and less than 10. Okay, and this column contains the numbers between 0 to 1. So this is the actual random number generated by the fortran program, and this is modified random numbers, and it varies according to the limits of the integration you provide. Okay, and these are the values. This is integral value estimated by Monte Carlo method, real value, and error in Monte Carlo method. This is how you can calculate the or estimate the integral value using Monte Carlo method for the limits of integration other than 0 and 1. So let's discuss 2D Monte Carlo method. Okay, so I think the video has been so long, so let me do little bit fast. I will provide these files to you in the description, and you can download the file from visiting the link provided in the description, and you can simply practice. Okay, and I recommend you to type the codes yourself. Okay, do not copy it from the file I have provided in the description. Okay, So this program helps to determine the two-dimensional integral by Monte Carlo method. We have in this case we will generate two set of random numbers. Okay, in previous two programs we generated only x here. Okay, one set of random number, and this is created from this actually. Okay, and we used only this as the variable of this function. Okay, but in 2D Monte Carlo method we will define two set of random number as x and y. Okay, and we will define a function of not only x or y, it will be the function of variables x and y. So that is why it is two-dimensional Monte Carlo method of integration. Okay, so and the function is not only x square, it is x square plus y square. Okay, other are same as before, and you have just name the program, initialize the program as program name, giving program name as MC2D integral. Okay, there is implicit none as well, and define double precision function externally as f, and there will be double precision a b c d as the limits of the integration, x y as random numbers, r will be also random numbers. Okay, and sum one will be the sum of the function, average of the function, integration estimated integral, the real integral, and error will be there. Okay, so I made mistake here. Okay, and I have also defined here integers as I and n, and in this case also you have to provide the lower and upper limits of the function. As there are two variables, we have to provide two sets of limits here, a b for x and c d will be the limits of y. Okay, and just insert the number of random numbers to be generated. Okay, this is n, and we call the as rand with the seed as much as greater. Okay, I have provided here from 1 to 9, same as before, and there will be someone first define 0.d0. Okay, and we use a do loop here, okay, for generating this number of random numbers. Okay, so do I takes value 1 to n. Okay, so r is random number here, and we modify it as x and y according to the limits of the integration you provide. You can see also here. So we actually generated x as random number here, and we modified to y as lower limit plus x times b minus a. Okay, same process is applied here. Okay, x is here, r is the random number generated from this. Okay, and x is modified the form of r, a plus r times b minus a as before, and there is y also, and which is c, lower limit plus r times d minus c. So here b and d are the lower limits of upper limits of x and y respectively, and there will be sum1 is equal to sum1 plus this sum1 plus f of x y. So this is a function of modified random numbers y and x and y, and n2. This will calculate the sum, and from using this sum value we have to calculate average of the function. Okay, average of this function actually. Okay, this average means average of this function, which is sum 1 by n. An integral will be difference for the limit of x, difference times difference of limit of x times difference of limits of y times average value. Okay, so here we have one-dimensional integration. So here difference is b minus a, and but here is two-dimensional, so we have two differences here. Okay, this and this times average value, and this prints the calculated or estimated integral value like this. And we also calculate or estimate the error in percentage. For this we have to know the real integral, and for this function real integral for the limits a, b and c, d is for x it is b cube plus b cube. Okay, you can simply try it yourself. So it will be b cube plus d cube by 3 minus a cube plus c cube by 3, because it is actually b cube minus a cube by 3 plus okay d cube minus c cube by 3. Okay, and I just simplified it to find this value. Okay, and in place of 3 I use 3.d0 for double precision. Okay, and error value will be real integral minus integral by real integral into 100. So let me use here absolute. Okay, ADS. Okay, there, so that there will be no negative percentage, because percentage are always in positive. And this prints the real integral value as this, and this prints the error in method, error with percentage symbol. Okay, and this ends the program. So this is how we write the code for 2D Monte Carlo integral. Okay, so let's run this program, 2D MC integral .f90. So let me clear it first. Okay, and just type g fortran and see there is in the file there is a 2D. Okay, so if I type just 2 capital D and press tab, it automatically shows the remaining names, and press enter. So the program is correct, there is no error. So just type to see the output as a.out and press enter. So it says after running the program, insert lower limit and upper limits of first variable. First variable means x. Okay, so you can insert any numbers. Okay, so that upper limit is greater than lower limit. Okay, remember, keep this in mind. Okay, so let me insert it at 1 and 5. Okay, for x, and for y let it be as 3 to 6. Okay, and insert number of random numbers to be generated, let it be 10,000. Okay, and it will show the random result as calculated or estimated integral value is this. Okay, and real integral value is this. Okay, and in error in method is negative, it says negative. So I forget to save the file here. Okay, let me save it first, so that there will be no negative sign in here. Okay, so let me repeat the same. Okay, it is 1 to 5, 2 to 6, sorry, 3 to 6, it is 10,000. Okay, see there is no negative, and it has very large error. Okay, so let's try with another limits. Okay, first of all let's clear it. Okay, so let it be 0 and 1. Okay, let it be 1 and 10. Let the random numbers be very large. Okay, so that there will be less error. Okay, if you press enter, then what will be the output or results? It is taking time, let's wait. Okay, because I have provided large numbers of random numbers to be generated. Okay, now see, as large as you provide the number of random numbers, the more you will get the precise value. Okay, so for this you get estimated integral value by Monte Carlo method is this, and real integral value is this, and error in method is, you see, it is now 0.8 percentage. Okay, you can provide as large this value. Okay, so this is how you can estimate the integral value using Monte Carlo method. Okay, this is for two-dimensional integration. I have already discussed about one-dimensional. So this was in video. Thank you so much for watching. If you want to download the files, you can visit the link provided in the description. If you found this video helpful, please subscribe the channel and don't forget to like it and share it with your friends. Thanks a lot.